A third way to solve right triangles is by using trig functions. You want to use trig functions when you have a right triangle and you only know one side and an angle inside the triangle. The three trig functions that we're going to use are sine, cosine, and tangent. So if you look at the right triangle, you're going to see an angle marked. From that angle, we need to realize what the opposite side is, what the adjacent side is, and then your hypotenuse. Hypotenuse is the easiest one to see. It's the one that's always across from the right angle. So you go to the right angle, go across, that's always your hypotenuse. Same kind of thing for opposite. Based off that given angle, if you go across the triangle, you will be at the opposite side. The side that touches the angle is called your adjacent side, because adjacent means touch or share. Right? So every triangle that is given to you will have to have an angle marked, or an angle given to you. Base everything off that angle. So for sine, trig functions are all about ratios. The ratio for sine is your opposite side over your hypotenuse. Cosine, still using the same triangle, the ratio for cosine is your adjacent side over your hypotenuse. So whatever the length of your adjacent side is over the length of your hypotenuse, that will be the cosine. And then finally we have tangent. Tangent is the opposite side over the adjacent side. Opposite over adjacent is tangent. The phrase that you should use and write down every problem you do or every worksheet you work on is SOHCAHTOA. SOHCAHTOA will help you remember what sides go with which functions. So in SOHCAHTOA would be sine is opposite over hypotenuse. The ka of SOHCAHTOA is cosine is adjacent over hypotenuse. And TOA, tangent, equals opposite over adjacent. Right? So get used to writing down SOHCAHTOA. So for example 1, I'm going to write SOHCAHTOA at the top just so we can reference it. I now want to label my sides so I know which sides I'm working with. Right? If I go opposite the right angle, I'm at my hypotenuse. If I go opposite the angle, I'm at the opposite side, which means the 25 has to be the adjacent side. It's right next to 36. So I don't know anything about the hypotenuse at all, so I just need to leave that alone. But I do know the opposite side and the adjacent. So you look for which function has the O and the A. Right, so that's OH, don't want that one. That's AH, don't want that one. We want OA. So we want the tangent. So what we're going to do is the tangent of the angle. So the tangent of 36 is equal to my opposite side, which is X, over my adjacent side, which is 25. If you had a calculator, we have to use a calculator to find out tangent of 36. To do that in your calculator, there's a button that says tan on it. So you would just hit tan, plug in 36, and hit enter. If you do that, you get the decimal 0.726 equals x over 25. Alright, we are solving for x. So to get x by itself, I need to get rid of the fraction. So to get rid of the fraction, I want to multiply both sides by 25. Alright, so 25s would cancel out, and I would just have x on this side. Apply 25 times 0.726, I would get, it'd be about 18.1, so we're going to say that the opposite side is approximately 18. So for the next example, I've already went ahead and wrote SOHCAHTOA at the top. Let's label the sides. So opposite the right angle is my hypotenuse. opposite the 48-degree angle is 10. So this is my opposite side, which leaves this to be my adjacent. Now look at the sides that we know. I know my opposite is 10, my hypotenuse is x. So which function is opposite and hypotenuse? Which one is O and H? Would be sine. So sine of the angle, which is 48 degrees, is equal to my opposite side, which is 10, over x. There's a little bit more work involved in solving this one. Since x is on the bottom, we're still trying to solve for x. I need to get x out of the bottom of the fraction. To do that, we're going to have to multiply both sides by x, which gives me x sine of 48 is equal to 10. And then I'm going to want to still get x by itself, so I need to divide both sides by the sine of 48. Once again, you'd have to use a calculator to figure this out. Sine of 48 would cancel out, so I would just have x. In the calculator, if you do 10 divided by the sine of 48, you would get 13.4, so we will round that down to 13. So the hypotenuse would be a size of 13. And our final example, SOHCAHTOA is written at the top, so let's go ahead and label the sides. My hypotenuse would be here, adjacent is at the bottom, and opposite would be across the triangle from the 65. Alright, so we're given the adjacent side and the hypotenuse, so we're given the A and the H, so I'm going to use CA, which is the cosine. So cosine of the angle, cosine of 65, is equal to my adjacent side, which is x, over the hypotenuse, which is 52. Alright, first I need to find the cosine of 65, which is 0.422. Then I want to get the x by itself, so I need to multiply both sides by 52. These 52s would cancel out, so I just have x. And 0.422 times 52 is 21.9, so we're going to round that up to 22. So the adjacent side, BC, would have a length of 22. So SOHCAHTOA, remember that phrase, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent.